Hi, everybody, and thank you for joining us today for our webinar, The Truth Behind the Health and Safety of Fiberglass and Mineral Wool. My name is Kim Melton, and I'm going to be co-hosting today's presentation with Bruce Ray. But before we dive into introductions, I would like to go over a few logistics. If you have any questions or concerns throughout the webinar, you can submit them at any point during the presentation via the Q&A feature, and we'll address these questions live at the end of the presentation. But if you don't see a Q&A to the right side of your screen, look for the series of circular icons at the bottom in the middle and select the icon with the ellipsis, and that's going to open up a menu with an option for Q&A at the top. Select that option and the dialog box to submit questions will open to the right of your screen. Additionally, we're going to follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we did today. You can ask any additional questions you may have about the topic of the webinar, or you can even suggest new topics for today's webinar that you'd like to, or I'm sorry, for any webinar you'd like to hear in the future. We're continuously striving to improve and evolve these webinars. So if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark, we definitely welcome your feedback, and we use that feedback to improve our webinars and provide the information that has the most value to you in future webinars. Now, this survey is also part of how we deliver the JM experience to you. So the JM experience is based on 4 pillars of the JM culture: people, passion, perform, and protect. And we believe it's critical to make sure that we hear and understand and respond to your needs in order to deliver the best interaction with you. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But we understand that that's not just a one-way street. Your feedback is a key component to helping us evolve to better meet your needs. Also, we're frequently asked whether or not we send out these presentations upon their conclusion. While we don't send them out, we do post a recording of it online for you to watch at your leisure or share with your colleagues. And this ensures that you can have the presentation within its full context, reference what we've said today, and even send it on to colleagues or friends if you find that it would be helpful for them. So we'll send that to an email to you once it's live on our website. So with that, we'll get started with some introductions. I'm going to hand it over to Bruce Ray.
Good afternoon, everyone. This is Bruce Ray, and I have the pleasure of being Associate General Counsel here at Johns Manville, where I also serve as Director of Governmental and Regulatory Affairs. Just want to let you know, I've been at this for a while. I'm in my 30th year at Johns Manville, and I've been focusing on fiberglass and mineral wool hazard and regulatory issues for over 25 years while at Johns Manville. And then prior to Johns Manville, I served in US EPA, where the focus of my efforts was in the Superfund program, which has a lot to do with risk assessments, hazards, and exposures.
Thanks, Bruce. So my name is Kim Melton, and I am the Technical Content Strategist here at JM. I haven't been here quite as long, only 5 years, but I'm responsible for the fiberglass health and safety content that you're going to see today and a lot of what we've published. So I'm also a Technical Content Manager. I handle a lot of the collateral that we develop for our HVAC, mechanical, and industrial businesses. So with that, we're going to go through some basics. And we're going to go ahead and get started with a bit of vocabulary to talk through the vernacular you're going to hear us using today. So this field of study obviously has its own vernacular, like most fields of study do. And here are a couple of words that you're probably going to hear. You may know them, you may not. So this is just to give you a bit of a groundwork to work from. The first one is a synthetic vitreous fiber, and this includes all form of manufactured inorganic fibers like glass wool or mineral wool, also known as rock wool or slag wool. You may have heard this also referred to as a man-made vitreous fiber. For today's purposes, we're going to refer to it as an SVF, but MMVF is also an interchangeable word used to describe it. A biosoluble fiber is a fiber that's capable of being dissolved in the lung or in vivo after inhalation at a fast enough rate that there's no health hazard presented to the person or being that's inhaled it, save for potentially some temporary mechanical irritation. In contrast, a biopersistent fiber is a fiber that is typically capable of being dissolved in the lung, but at a much slower rate, and is much more likely to cause hazard to the living creature that has inhaled it. KDIS stands for your dissolution constant, and that's an in vitro measurement of synthetic fiber solubility. Basically, we take a fiber, we put it in a simulated lung fluid called Gamble solution, and determine how quickly it dissolves. And this is used to predict in vivo biosolubility, or how quickly it will dissolve in the lungs of a living creature. a macrophage is a scavenger cell, and so that's a scavenger cell. They exist throughout your body, but they also exist in your lungs, and they ingest inhaled foreign particles, and they basically go through your lung systems and they clean it up. Macrophage quite literally means large eater. Think of it kind of like a Pac-Man. So the next one is a special purpose fiber. Those are glass fibers that are used for non-insulation applications, and basically they're commonly used in filtration, battery separator paper. These are not fibers that are available to the general public. They're not typically used in building manufacturing, and they comprise no more than 1% of all glass fibers manufactured. IARC is the International Agency for Research on Cancer. They're part of the World Health Organization, and they are the keeper of the official international carcinogens list. Then we have the NTP, that's the U.S. National Toxicology Program, part of the Department of Health and Human Services, and basically they're the keeper of the U.S. carcinogens list. The final word we'll go through is binder, and that's basically the glue that's used to hold fibers together in fiberglass or mineral wool, and also offer rigidity and tensile strength to fiberglass or mineral wool insulations. So as we start talking a little bit about the science here today, there is a hierarchy of data that's used to determine hazard. And this data is, you have a variety of types of studies that have been done, everything from human data to animal data to in vitro data. So basically, as we look at the type of data being released by this research, we're able to see that you have different types of data, different types of research that's being done. And as we explore this, we are able to see that some data holds more weight when we're determining what causes hazards to humans. And so we have human data, which counts as epidemiology, and that's basically your holy grail of data. That's the data that holds the most weight as we're determining hazard. As we step down from that, we have animal data. That's data or research that has been collected based on animal studies, and we refer to that as in vivo. Then we have in vitro data, and that's data that's collected through laboratory simulations. So you're not actually looking at live lung tissue, you're not looking at animals, you're looking at simulations just like Gamble's fluid. And then finally we have chemical data. And chemical data refers to the type of data that is basically your chemical physical properties of a substance, and you're able to make conclusions or make decisions based on how we know these chemical properties to react. So why are we here today? Today is why are we as Johns Manville here today? And so the industry has a very unique approach to this. The insulation and mineral wool industry, the fiberglass industry, has a very unique approach to SVF hazards, and it's called IPC. And that stands for Investigate, Publish, and Communicate. So not only are we working to create materials that are helping improve building efficiency and energy efficiency, but we also want to make sure we're doing that safely and not providing materials that are hazardous to humans as they are going into these buildings, as they're being installed, as they're being manufactured. So we have a principle to investigate any possible hazards via transparent scientific studies and reviews, publish and communicate these reviews or these scientific studies, and then communicate those hazards to anybody who may be interacting with the materials. So with that, I'm going to hand it over to Bruce, and he's going to talk about where we are today in terms of science, hazards, and regulation.
Thanks, Kim. I'm going to get right to the point, not keep you in suspense till the end of the webinar for the conclusions. I'm going to give them to you right up front. Here is where we are today, probably the most important slide in the webinar today. Here's the conclusion. Insulation, glass, and mineral wool fibers are not classified as carcinogens. There was a lot of new animal science as well as updates to human epi science that was developed in the 1990s, early 2000s, and all that new science has been recognized by national and international authoritative scientific and regulatory bodies. The cancer warning labels are not required by law on these fiberglass and mineral wool insulation products. So we have new science showing no cancer hazard by inhalation, but we've also done a lot of work to understand what are the exposures to glass fibers and mineral wool fibers, not only in manufacturing, but in residential and commercial indoor environments, and that exposure is actually very low. I want to get now into a little bit to the, that's where we are today, but I think to really understand why we are where we are today, it's important to go into the history of the research here. It's important to understand that in the 1970s and 1980s, there were some early studies done by the Fred Pott, Merle Stanton teams that showed tumors and fibrosis from exposure to fiberglass mineral wool in rats. The problem with these early studies were that the glass fibers were surgically implanted in the rat peritoneum, which is the membrane around the abdominal cavity. And unfortunately, when you bypass the natural defense mechanisms of the lung and of the body, and you just place lots of fibers inside the body like that, you do tend to get peritoneal tumors. And you can see references to some of the studies there. Now, when the International Agency for Research on Cancer, or IARC, was looking at fiberglass and mineral wool and looking at what available data there were in 1987, they were trying to find a way to fit those early intraperitoneal injection studies into their classification scheme on cancer hazard. And you can see that there are various categories there. And one of the things that they look at was the relationship, how they should weight these intraperitoneal implantation studies. Now, IARC has a matrix approach to how they make cancer hazard classification decisions. As you can see, they look at both the human evidence in humans as well as the evidence in animals. The evidence in humans on fiberglass and mineral wool has always been inadequate. But they looked at those early IP studies in 1987, and that's all they really had, and they judged that those were sufficient to make a cancer hazard classification, because that's basically all they had. And they then placed fiberglass and mineral wool in a Group 2B classification, possibly carcinogenic. Again, although the industry pointed out to the IARC panel in 1987 that really it's they should make their hazard classification based on inhalation studies in animals, IARC said that there were no well-designed animal inhalation studies to look at that time. The impact of that Class 2B classification by IARC really had some consequences in the U.S. Under the OSHA Hazard Communication Standard in the United States, IARC is recognized as an authoritative scientific body, so that if IARC classifies something as a carcinogen, OSHA pretty much has to treat it as a carcinogen as part of the hazard communication program. In addition, in 1994, the National Toxicology Program, which is the official keeper of the U.S. list of carcinogens, looked at that IARC 1987 classification as a possible carcinogen, and itself listed glass wool as its own in the own NTP classification system as reasonably anticipated to be a carcinogen. Well, what this meant basically was that, starting in the late 80s into the 90s, we then had to put cancer warning labels on the fiberglass and mineral wool products. Well, not surprisingly, after IARC made its classification decision in 1987 and said that there were no well-designed animal inhalation studies, the industry went about essentially designing really good animal inhalation studies. And what they had to do was, and just to understand this is the kind of industry that we're dealing with here, we spent millions of dollars to invent essentially a new science, a new way to expose test animals to respirable fibers. And once those study protocols were developed and finalized, we did carry out the long-term animal inhalation studies at RCC in Geneva, Switzerland. This was starting in about 1990. Importantly, 2 species of animals were tested, both rats and hamsters. Hamsters were tested because it was thought they were more sensitive species. And we had different types of fibers that were tested in these long-term studies. First, of course, we had the insulation fiberglass and mineral wool fibers. We also tested special purpose fiber. And then also, what was extremely important to serve as a positive control, we did test asbestos in there as well. Importantly, we call these long-term studies. They lasted 24 months, which is essentially the entire lifetime of the experimental animals. And then what we would do is we have an unexposed cohort of these rats, and then we would have exposed rats. And then throughout the study, we would sacrifice some of the rats at, say, 3 months, 6 months, 12 months, so that we could understand what was going on in the rat lung as the study was progressing. The results of the animal studies were that for the asbestos-exposed animals, there was tumor proliferation. That was good because it told us that the way we had designed the inhalation protocol, we were getting some good respirable fibers into the lungs of these rats. Some of the special purpose fibers showed that there was some fibrosis in tumors. The good news on the insulation classical and mineral wool fibers was that we found no fibrosis and no tumors. And as part of the interim sacrifice of the rats and looking at the lungs during this long-term animal inhalation study, it was interesting because we had kind of a counterintuitive observation being made. These interim analyses showed that as these time progressed after exposure, these rat lungs, it had a higher fiber count than at the initial exposure. And as I said, that was counterintuitive and kind of an unexpected result, but it was a key to the mechanism of fiber-based carcinogenesis. Here is probably another one of the really important slides in the webinar today. The most important conclusions that we drew from these animal studies is that cancer hazard of fibers is controlled by the 3 Ds, and by that we mean dose, dimension, and durability. Dose is essentially respirability of fiber, the ability of the fiber to be deeply inhaled into the alveolar sacs deep in the lung. By dimension, we mean the longer fibers, and especially fibers that are longer than a macrophage, those scavenger cells, are in diameter. So we're looking at fibers longer than 20 microns. And then also, very importantly, we understood now that durability plays a key role. If a fiber is very persistent in the lung, it leads to chronic inflammation, followed by cell repair and proliferation, which can lead to fibrosis and ultimately to tumors. And remember, when we say 3 Ds, it means all 3 have to be present for a fiber to have a possible cancer hazard. If you had dose and dimension, but no durability, it's not a hazard. Also, if you had dimension and durability, so that you would have long fibers that were durable, but no dose and they're not respirable, again, no hazard. If you had only dose and durability, short durable fibers, again, there's going to be no hazard. You have to have all 3 present: dose, dimension, and durability. And we did find out that what led to the solubility of these insulation fibers are 2 things: the chemistry and the morphology. That is, again, the shape of the fiber. This slide shows as cells interact with synthetic vitreous fibers. If you have a long fiber longer than 20 microns, we've seen in these, as a result of the studies, that you can have both congruent as well as incongruent dissolution. Congruent dissolution, we see frequently the fiber dissolves just completely. In incongruent dissolution, you can see that we have transverse breakage, so that one fiber, the way you count it when you're doing your electron microscopy, one fiber can actually become 4. And as you can see, that was the reason why we had that counterintuitive result, that as the study went on, we actually saw more fibers, more structures. And then you can see what happens as there's transverse breakage, and what we see is we have macrophage uptake, and essentially the macrophage will march these fibers, shorter fibers, out of the lung via the mucociliary escalator. I have a short animation here to show you, kind of to depict what happens to a durable fiber that has been deeply inhaled and how a macrophage would go about attacking it. So we have this long, durable fiber, deeply inhaled. The macrophage comes along and it tries to engulf the fiber. And because it cannot engulf the fiber, the fiber is longer than the macrophage is in diameter, we see that the macrophage will essentially die in the process of trying to dissolve that fiber. And as a result of that cell death, the macrophage will leak out low pH enzymes and other reactive oxygen species. We understand now that that is followed by rapid cell division and proliferation and possibly fibrosis in tumors. Now compare that then with the interaction of a macrophage and a biosoluble fiber. The macrophage may try to engulf the fiber, but because the fiber is soluble and it does react to the low pH enzymes released by the macrophage, it will essentially cut that fiber into many smaller structures, and then other macrophages will come along and take those out of the lung. And we have a much longer explanation of this mechanism of fiber clearance. If you want to just video John Hadley on YouTube, he's got about a 20-minute video explaining in much more detail how this happens. So
Bruce obviously talked about the in vivo studies of the animals, and that, as I mentioned earlier, was in the second tier of our hierarchy of determining a hazard. I'm going to discuss our epidemiology studies, and these are actually epidemiology studies done on people for fiberglass and mineral wool. So the method was fairly straightforward. We took a population of fiberglass and mineral wool manufacturing workers who are obviously, they're manufacturing this materials, they're going to be exposed to the fibers throughout the manufacturing process. But the researchers reviewed their death certificates for the cause of death, and then they compared that cause of death from the exposed population to the unexposed population to determine whether or not workers had a higher rate of respiratory cancers or non-malignant respiratory disease. So basically, we took our manufacturing workers to determine whether or not they were exhibiting cancers that the unexposed population was not exhibiting. Now, the data includes nearly 1 million person years of exposure. So basically, we have, you have somebody who has 5 years, 10 years, 11 years. That's cumulatively, you're taking all those person years, and we have, as a accumulation, of nearly 1 million years. The exposure period was from 1945 to 1992, and the results were actually as we expected. The respiratory system cancer rates were not any higher in the exposed population after we controlled for confounders like smoking. Interestingly, the duration of exposure or cumulative exposure to respirable fiberglass or mineral wool also did not have an impact or didn't have an associated risk with respiratory system cancers. So someone who was exposed for 20 years versus someone who was exposed for 5 years did not have a higher risk of developing a respiratory system cancer as a result of exposure. There was no apparent trend with increasing exposure. As of 2001, they actually did an update, and this status confirmed that the role, they reviewed the animal science, and they confirmed that the role of fiber durability in cancer hazard was significant, and also it demonstrated that insulation SVF are sufficiently biosoluble that they have no cancer hazard. And then they also reviewed additional data on the epidemiology, and they, again, confirmed that the rate of respiratory system cancers in fiberglass workers was not higher than the unexposed population. This data has actually also undergone review again in 2019 as a meta-analysis. Any new research that's been released on it has been reviewed, and the meta-analysis found that the 2019 findings were consistent with the previous findings, and that research is going to be released either later this year or at the beginning of 2020.
So in 2001, we have the Epi Study update of our million person years of exposure showing no increase in the incidence of respiratory system cancer. We also had the results from the animal inhalation studies that confirmed the role of dose dimension and durability in fiber hazard. So we went back to IARC and had them review the new science. And what they did was they looked at the new animal studies, and they looked at the totality of the animal studies, gave more weight to the more recent studies, and then moved the IARC classification there from a 2B to a 3, and showing that, as with the new science, instead of being sufficient evidence of cancer in animals, it was really only limited. Now, that is for the insulation, fiberglass, and mineral wool, and that's where it's been since 2001. importantly, the special purpose fibers proved more durable, and we did get some positive results in some of the animal inhalation studies, and those special purpose fibers were kept at Group 2B, where they remain today. After IARC did the reclassification, the downgrade of insulation, fiberglass, and mineral wool in 2001, NTP also changed their classification. Recall in the early 90s, NTP listed glass wool fibers as reasonably anticipated to be a carcinogen, but in 2011, NTP in its 12th report on carcinogens reviewed all of the new science and essentially removed from their list of reasonably anticipated carcinogens those glass fibers that had been successfully tested in animals. Now, if you go to look at the NTP's substance profile, the summary of their reasoning for their downgrade in 2011, they took a different pathway to that conclusion than IARC did. IARC basically said, the insulation fibers, they're not as durable, no cancer hazard. Special purpose fibers, more durable, possible cancer hazard. The NTP didn't look at the use. They didn't make their hazard classification decision based on the use, but merely on the durability as shown in an animal test. So basically what the NTP did in 2011 is essentially recognize that there's only certain fibers that are reasonably anticipated to be a carcinogen, and any fiber that had been successfully tested in an animal is not considered a carcinogen in the U.S. And therefore does not have to have a cancer warning label. And again, this is another critical distinction between special purpose fibers and insulation glass and mineral wool fibers. In the United States, it's not just enough to have IARC do the classification as well as the National Toxicology Program. From a practical standpoint, we also have to make sure that California Prop 65 is recognizing this new science, and they did. As of November of 2011, it's really only the respirable, durable fibers that are covered under Prop 65 where you have to have a cancer warning label. I want to tell you a little bit about some of the more, as Kim touched on this, but I want to go into a little bit more detail on the updates to the epidemiology study. The big study update was done in 2001. We prepared an update to that 2001 study in 2009, presented that to the National Toxicology Program's Board of Scientific Counselors for their review, and this was one of the documents they relied on in 2011 in downgrading fiberglass. But in addition, as Kim touched on, we have Drs. Marsh and Egnott have recently completed a meta-analysis of all of the post-2001 cancer, fiberglass and mineral wool cancer epidemiology studies. Their conclusion is no study published since 2001 has found an increased incidence of respiratory system cancer, thus validating the downgrade that IARC did in 2001. This article has been submitted to the Journal of Occupational Environmental Medicine, and we hope that that will be published, if not in the fourth quarter of 2019, in the first quarter of 2020. We are rounding out the additional Epi effort there. Drs. Marsh and Egnott also have well underway a new meta-analysis looking at all of the post-2001 Epi studies done on non-malignant respiratory disease, and those studies will be published in 2020 as well.
So let's talk a little bit about exposure levels. Obviously, you know, you have people working in manufacturing facilities, you have people in office environments where fiberglass can be in the ducts or in the walls. And the question is, are people, what are the exposure levels in manufacturing facilities, and what are the exposure levels in offices and residential buildings? And so these are great questions. And so NAMA actually has a robust occupational exposure database covering exposure in a variety of worker environments, from manufacturing to installation to retrofit to removal. And as of 2019, this database has more than 18,000 industrial hygiene data points. And the findings from this data report that, in general, even the people who are working with fiberglass and mineral wool insulation in these manufacturing or installation applications are under pretty generally low exposure. and generally less than 1 fiber per cubic centimeter, and that is the 1 fiber per cubic centimeter is the OSHA NEMA voluntary permissible exposure limit. Anything greater than, if you're in an environment where you are in fiber concentrations in the air of greater than 1 fiber per cubic centimeter, OSHA NEMA recommends that there's a voluntary recommendation of wearing a dust mask. And what you can see in these pictures here, one, you have a personal industrial hygiene sampling in the picture of the guy on the top there, and he's basically he's wearing that as he's going about his everyday use, and it is collecting air samples constantly as he's working. And then you get a little bit closer up review of what the machinery is that is collecting the samples there on the bottom. So the OSHA database actually found that the mean exposures for every insulation industry sector that I listed above are below 0.4 fibers per cubic centimeter, and the medians are all below 0.25 fibers per cubic centimeter. Interestingly, even the 95th percentile of the highest exposures are still well below 1 fiber per cubic centimeter of the voluntary permissible exposure limit. So what we're encountering here is that even people working with this material are really not being exposed to incredibly high fiber concentrations in the general air that they're breathing. Now, as we look at residential and commercial applications or environments, they actually did a study, Carter et al. Did a study where they did air sampling in these environments and to collect fibers and see what people were inhaling in the air that they're breathing in their everyday offices, et cetera. And what's important about this is the fibers were counted as well as speciated using optical and electron microscopy. And this is pretty key here. So generally the results found that the respirable fibers in indoor environments are very low, 0.008 respirable fibers per cubic centimeter as an average, even a maximum of 0.029. And 97% of those respirable fibers are organic in nature, meaning they're coming from drapes, dust, carpets. These are not the SVF fibers that you're getting in insulation. The inorganic fibers, like fiberglass or mineral wool, make up less than 0.0001 fibers per cubic centimeter. Importantly, even 205 samples that they took, these inorganic fibers were only present in 2 of them. So what that says is that no, these fibers are not really being released into the general airstream. They're not being released into the breathable airspace that people are occupying on a day-to-day basis. Now, as you look at using fiberglass in an HVAC system, like a fiberglass duct liner, it's a valid question to ask, does the airstream cause fiber shedding? And that's a great question. Now, the answer to that is unlikely. So to use a fiberglass duct liner in an HVAC system, it has to undergo really rigorous UL testing. And this UL testing requires that the insulation be tested under basically what are hurricane force winds, which are 2.5 times as fast as the top speeds that the insulation would encounter in its application. So our fiberglass duct liners are rated to 6,000 feet per minute. That means in this UL test it has to undergo 15,000 feet per minute air speeds without showing any signs of delamination, shedding, or erosion in order to pass this testing. On top of that, most of our duct liners are coated with permacoat coating, and this is an antimicrobial coating on the airstream surface. And it's designed to prevent mold intrusion in the insulation surface, but it also happens to prevent loose fibers from entering the airstream, serving as almost a glue or a casing, if you will, over the insulation that prohibits any fibers from being released. And as you can see in that picture there, that's the black coating you see on the yellow insulation. If we look at fiberglass exposure outside manufacturing facilities, that's something else that has been tested, and generally it's the same as the rural background. So we're encountering very low fiber concentrations, even around manufacturing plants outside and around the area.
So I want to talk a little bit now about JM's policy on product stewardship and hazard communication. Shortly before I joined Johns Manville in 1990, Johns Manville made a commitment to its employees that they would investigate the hazards of all JM products, not just fiberglass and mineral wool, and that we would communicate around those hazards fully and on a timely basis. And back then, Tom Stevens, the Manville president, basically summed it this way: we will tell you what we know as soon as we know it. And a little bit more information here, detail about the industry's commitment to product stewardship. Our trade association, NAMA, the North American Insulation Manufacturers Association, has a formal product stewardship program. Now, this began as a collaboration between NAMA and OSHA, Occupational Safety and Health Administration, in what we called the Health and Safety Partnership Program. What the purpose of the collaboration between NAMA and OSHA was a couple of things. First, we wanted to make sure that we had really good hazard communication and education around how to work safely with fiberglass and mineral wool. OSHA also was concerned that back, say, 20, 25 years ago, we really didn't have a lot of data concerning exposure to these fibers in the workplace. And so they requested that we establish and maintain a comprehensive exposure database. Kim talked about that. We have over 18,000 individual data points in that exposure database now. We talked in great detail with OSHA about what limits should we try to shoot for in terms of a permissible exposure limit. And OSHA and NAMA settled on 1 fiber per cc as a voluntary permissible exposure as part of this program. And in addition, we developed comprehensive PPE, personal protective equipment recommendations. And those are fairly straightforward, such as wear eye protection, and then also long sleeve shirt, long sleeve pants, and then also gloves when you're handling fiberglass and mineral wool. Very important, we had lots of discussion with OSHA about respiratory protection. It was decided jointly that where we would have exposure greater than the 1 fiber per cc voluntary permissible exposure limit, that we would recommend to workers that they use a NIOSH N95 dust mask respirator. And you can see a picture of that on the slide there. Based on all of the data we have in the exposure database, really the only time that you're going to see fiber concentrations greater than 1 fiber per cc is when you're blowing loose wool, loose fill insulation, and only when it's really in an enclosed area such as an attic. And those are the times when we really do recommend that the respiratory protection is worn, although we would offer that to employees for if they want to wear that, even though if they want to wear a dust mask, even though the exposure is less than 1 fiber per cc, for their personal comfort, that's fine. We encourage that as well. And then again, just a little bit more detail on respiratory protection issues, something that we've looked at in very great detail. We know that the insulation glass fibers can cause temporary mechanical irritation. And that's not only when they're inhaled, but also on the skin. But it's very important to understand that this is just mechanical irritation. This is not an allergic respiratory reaction. Fiberglass does not cause asthma, does not cause respiratory sensitization, and even durable glass fibers are non-allergenic in this manner. So going forward, we have all the animal data, all the animal tests. We have the epidemiology tests. What do we see in the future in terms of testing around fiberglass? Looking forward into the future, we see that there's going to be a definite trend of moving away from animal testing. This is well underway in the European Union, and just this year, both the National Toxicology Program as well as the US EPA have expressed their intent to try to move away from doing animal testing. And what this means for fiberglass and mineral wool is that there's going to be more of an emphasis on in vitro K-DIS testing, especially as you develop new glass fibers. And as Kim stated, the in vitro testing is really where you place fibers in simulated lung fluid, such as Gamble's solution, and then the K-DIS method then measures mass loss over a specific period of time. And it is interesting to note, we are not starting from zero, not starting from scratch on K-DIS in vitro testing. There's a lot of data out there. There have been several good journal articles written on this. And one of the things that we have found is that K-DIS of 100 is pretty much a generally accepted threshold in the industry. that if you look at all the fibers that have been successfully tested in experimental animals, they all had a K-dis greater than 100. And that, you see the reference there to the Walt Estes and John Hadley article. And this K-dis of 100 was endorsed by the NTP expert panel back in 2009. So I think we're going to see more developments on the K-dis in vitro testing. And in addition, the future holds that we're also going to see updates to all various studies and articles, whether it's on epidemiology, cancer epidemiology, non-malignant respiratory disease, on occupational exposure, non-occupational exposure, environmental exposure. This is an industry that, doesn't just stand on one or two studies. We like to see the scientific literature refreshed. We like to see updates done. So the takeaways, the final conclusions here that I think are, as I presented on one of the first slides, I hope you can understand after talking through all of the animal studies, in vitro studies, the Epi studies, synthetic vitreous fiber insulations are truly the most tested insulation available on the market today. And all of those studies confirm that synthetic vitreous fibers do not present a cancer hazard by inhalation. The second takeaway is that synthetic vitreous fibers are safe to manufacture and use when common sense precautions are taken to prevent temporary mechanical irritation. We talked about the PPE, gloves, long sleeve shirt, eye protection. And this is important too. We see a lot of other insulations may claim to be safe, fibrous and non-fibrous, but if you look really closely, sometimes they claim to be safe, but what they really mean is that they're untested. And there's a big difference between being untested and having a lot of science proving that you're safe.
All right, with that, I'm going to talk about some additional resources. First off, we have if you're looking for more information about this topic or other educational resources relating to insulation, we offer online training, a blog, a specifications portal, and recorded webinars, all in our online portal called The Source. And what The Source is it's where we host all of our recorded webinars, as you can see here in the tabs, like the one you've attended today. And you can watch these on demand. You can share them with colleagues. It also hosts our blog that contains original written content by JM, as well as curated content from experts throughout the industry. And our blogs hit on targeted technical topics like fiberglass and mineral wool health and safety, the latest news in the industry, and even scientific details that are critical to successful insulation system design and operation. And we strive to make this content as rich and relevant as possible so that it can better serve you and the information that you need and you're looking for as you go through and you go about designing your insulation systems. There's also a full library of helpful documentation on The Source where you'll find technical bulletins and white papers, product application guides. This is a great resource for anybody who's looking for really highly specific product application or specification information. And then finally, in the chat box on this, you should have received a link to The Source, but you can also find a link to it directly on the HVAC or mechanical or industrial pages of the JM website. Additionally, we have a similar resource for our OEM business, the OEM Engineering Portal. Similar to The Source, the Engineering Portal contains specification information for all of our OEM products, sustainability information, tools, and recorded webinars for anybody looking for information about that for our OEM products. And now, in addition to these resources, we also have an event called the Engineer Advisory Council, and this is basically it's a focus group of engineers who get together and they talk to us about some of the hot button issues they're facing in the industry, so we can discuss how JM can better help engineers address the problems and their pain points that they're facing. So if this is something you are interested in participating in, please let me know. You don't have to let me know specifically, but you can let us know in the survey. There's a question about it specifically in there, and we can reach out to you when it's time to have our next EAC. And finally, for everyone who attended the webinar today, you will be getting a certificate of completion. This will be emailed to you directly by Friday, and it should be in your inbox, and it'll be for 1 hour. So with that, we're going to go ahead and take it to some questions. We did have an option to submit questions ahead of time, and then we've also gotten some questions through the Q&A chat feature. So we're going to start with the questions that were pre-submitted, and we will go from there. You ready, Bruce?
Ready.
Awesome. So the first question is there a difference between modern fiberglass and older fiberglass from a health and safety perspective?
I would say not really. In terms of Johns Manville, we've been using the same chemistry and manufacturing method for decades. This is the rotary Herm process. And, you know, for decades, we've been using what's called the 901 chemistry formulation. And 901 was also known as MMVF10, which was successfully tested in the long-term animal inhalation studies in the early 1990s. And so that's the fiber that we use today, you know, for our light density bats and rolls is essentially the same fiber that was successfully tested at RCC.
Excellent. Well, that answers the next question, which is how do we know that the fiber tested years ago is the same fiber in use today? I think that pretty much summed up in your last answer.
I would just add that we understand very much the design chemistry of the 901 fiber, and we make sure that we keep that chemistry constant so that any changes in chemistry do not affect the durability of the fiber. And it's you know, we really have to keep the chemistry very steady in order to have a good manufacturing process anyway.
All right. Are there any safety improvements in the JM fiberglass going from the brown binder back to the white acrylic binder?
That should have no impact on health and safety. It should have no impact on thermal or acoustic performance. The only impact is visual, and since it's usually going to be behind a wall, it really shouldn't have any impact at all.
Excellent. Is there a health risk using these materials as part of a manufactured product?
No, I mean, we do have fiberglass incorporated into products, you know, that are fabricated into other insulation products, and there is no risk, certainly no increase in risk of taking an otherwise biosoluble fiber where we have no hazard and incorporating that into another product. So really, no, there is no increase in hazard.
Okay. The next question is, what is the difference between fiberglass and mineral wool? And from a performance perspective, they're different raw materials. Mineral wool is made from basalt, while fiberglass is obviously made from glass. From a performance perspective as well, mineral wool can go to higher temperatures, about 2,000 degrees, whereas fiberglass usually stops around 800 to 1,000 degrees. And a lot of that has to do with the binder as well that holds the materials together, which usually burns off around 400 to 600 degrees. From a health and safety standpoint, Bruce, to address that?
Well, in the fibers themselves, there's really no distinction in hazard between a glass wool fiber and a mineral wool fiber. Both glass wool fibers and mineral wool fibers were tested in the experimental animals, and both types of fibers were included in the epidemiology studies.
Awesome. Is there any hazard to skin?
The potential hazard to skin is from temporary mechanical irritation that you know, you can experience some irritation, some itchiness, and it comes really from the coarser fibers, the fibers that are larger in diameter, say above 5 microns. But we do know it is temporary, so that the irritation does subside when the exposure is discontinued.
All right. Now we're moving into questions that have been submitted today, and so we'll start at the top here, and that is, do you require those working with fiberglass to use any sort of mask over their nose and mouth while working with the material?
We touched upon that in the respiratory protection slide and the product stewardship slide, where your exposure to glass or mineral wool fibers is going to be above the voluntary permissible exposure level of 1 fiber per cc, and I would say that's a time-weighted average over an 8-hour shift. The recommended personal protective equipment is that NIOSH N95 dust mask respirator, and we showed a picture of it. For exposures below 1 fiber per cc, it's not, you know, really potentially necessary or recommended, but certainly a lot of people, for their personal comfort, like to wear that whenever they're working with fiberglass or mineral wool.
All right, about the studies that referred, the epidemiology studies that referred to manufacturing workers and unexposed people, were the workers using any sort of respiratory protection in the study?
Typically not. You're talking about workers and exposures going back to 1945 all the way through, I think it was like 1995. Typically those historic exposures in the manufacturing plants were higher than they are today, and I am to understand that respiratory protection was less frequent years ago than it is today, so that in many respects those epidemiology studies are the result of looking at kind of worst case exposures, higher exposures in the past where hardly anybody wore any kind of respiratory protection.
Okay. Are there any health reasons to use the new white acrylic binder versus what JM was previously using? And I think you kind of already addressed this, but... No,
it's the change in the binder formulation has no impact on health and safety, thermal performance, or acoustic performance. It's really just a visual change.
All right. Is there any way to correlate the KDIS, or the dissolution rate, and chemical composition of the fiber?
Yes, as Kim explained on one of the earlier slides, we have this hierarchy of data, with Epi being at the highest, followed by in vivo, and then in vitro, and then chemical. There have been several articles written by Bellman and others where you can look at just the bulk chemistry of a fiber and try to predict or estimate what the KDIS would be, and also try to predict and estimate what the fiber clearance time would be in a short-term animal inhalation test. So that, yes, we can use chemistry to guide whether we're going in the right direction of making a fiber as biosoluble as it needs to be. But again, it's better to go higher on that data hierarchy.
Okay. Is there any difference in health risk when using pot and marble versus spun wound glass?
Several of the journal articles published in the 1990s and then going into early 2000s noted that fiber durability is affected not only by chemistry, but to a certain extent by the method of manufacture. So that we do see that, for example, at Johns Manville, the fibers that are, even for a given identical chemistry, if you produce a fiber on a rotary herm, it is going to be more biosoluble than produced on a pot and marble flame attenuated process. And the reason is that the way the fibers are attenuated in the herm process is by pressurized air, and you tend to have a much larger surface area on those fibers, so that the lung fluid will attack it more rapidly, whereas the pot and marble fibers being flame attenuated, you get that kind of glassy annealed surface that is a little bit more durable.
All right. Do you recommend minimizing the use of fiberglass duct liner?
No, I think fiberglass duct liner is a proven solution to consistently provide keep conditioned air conditioned until it's delivered to the living space. And it's got multiple decades of successful application and use. And in fact, I think one of the ways to improve the comfort of conditioned spaces, whether it's residential or commercial or office, is to make sure that you have consistently conditioned air delivered to the occupied spaces. And using either fiberglass liner or duct board is a great way to do that.
I'll add to that, Bruce, in answering that question. You know, a lot of the exposure studies that have been done through NAMA and third parties have demonstrated that even when using fiberglass duct liner, you're still not getting fibers in the general air that people are breathing in the building. So in addition to being a proven and very economical solution compared to some other insulations out there, it's also safe. It's not shedding fibers into the airstream. As I said, it's tested to hurricane force winds without showing any signs of shedding or delamination. And so you've really got a very tried and tested material that has also demonstrated that it is resilient when used in an application such as air handling. What would be the best way to wash insulation off eyes and skin, or if ingested, what should one do to get help?
For eyes, first of all, for skin, again, you should be wearing long pants, long sleeve shirt. If you do get it on the skin and experience some irritation, it's always good to, irrigate it with water and a mild soap. That tends to help wash it away. For the eyes, again, recommend that you wear eye protection, but if you do get it in your eye, again, using eye drops to wash the eye out, I think would be important.
All right. And the next question is, what does the NTP stand for again?
That is the National Toxicology Program. It is a component of the Department of Health and Human Services, and the NTP is the official keeper of, in the United States, the official keeper of those substances and exposures where there is a possible cancer hazard. All
right. The next question is, what fiberglass products still fall under the California Proposition 65?
The only fiberglass, none of the insulation fiberglass or mineral wool products fall under Prop 65 today. The only fiberglass products that would fall under Prop 65 are certain special purpose fibers that are not available for consumer use generally. They comprise only, I think, about 1% of total fiber production. Applications would include fibers that are made for battery separated paper and lead acid batteries, and then certain fibers such as the Johns Manville 475 fiber that is used for high efficiency particulate air filters.
And just to add to that, there's none of the fibers used in our insulation for fiberglass in the walls, in your ducts, need to be listed under Prop 65.
Correct.
And then finally, have there been any studies done relating to binder burn-off with mineral wool at higher temperatures? And to give some context around that, mineral wool is, obviously it's made from fiber, so is fiberglass, and so it has a binder that adheres everything together. And that binder is frequently, in high temperature applications, like I said, between 450 to 600 degrees, mineral wool tends to experience binder burnout, where the binder actually oxidizes and burns out. So I don't know if any research has been done on that specific binder burn-off.
I don't recall any articles published on that, but it's well recognized that whether it's fiberglass or mineral wool, bonded products experience binder thermal degradation at elevated temperatures. So that anything, even range insulation, say above 450 to 500 degrees, but certainly high temperature pipe applications, that binder is going to burn off pretty early in service. And when it does, you know that it's going to give the typical thermal degradation products from organic chemicals. And I think we did have another question come in about fiberglass and mineral wool binders, and again, for the light density bats and rolls, certainly we're using an acrylic binder now, formaldehyde-free acrylic binder. For certain heavy density products and for mineral wool products, they will tend to use the phenylformaldehyde binder, and it is basically why we do that is that those products react very quickly and very completely, so that even if we have a formaldehyde as one of the components of the binder in the heavy density products, that formaldehyde will react essentially completely into a solid, into the final product. we will see very little formaldehyde off-gassing, and I think even our phenylformaldehyde bonded heavy density products do green Green certification for low emission.
All right, that wraps up all of our questions. We're just 2 minutes over time, so thank you everyone who decided to sit on with our questions today. Again, you will be receiving a survey right at the end of this presentation, and you'll be able to submit any questions that you didn't, or maybe you think of at the end of the presentation. You can submit any questions and we'll reach out to you directly. Also, if you have any interest in attending our next Engineer Advisory Council, please let us know via the survey. Otherwise, we hope you enjoyed your time and found this to be educational and helpful, and look for our follow-up email here in a week or so with the recording. Thank you so much and have a great day.